Okay, so let's do some more example here with on dice. Okay, so we're rolling two dice. One's a black one, and then the other one is a white one, just to keep them apart. Maybe I'm interested in the chance that I get a sum of 5 or sum of 6. Maybe if one of those two things happens, then I win a prize. First of all, how many possible outcomes are there? There are 36. Remember that from our picture there. Also, how many ways can you get a sum of 5? Think about it. 1, 2, 3, 4 ways to get a sum of 5, right? And how many ways can I get a sum of 6? How many ways can I get a sum of 6? 1, 2, 3, 4, 5 ways to get a sum of 6, right? That's 9 out of 36. So I did that by counting ways to satisfy those events, right? Counted 4 there plus these 5 there from that diagram, right? Here are my sums of 5, here are my sums of 6. So 4 sums of 5 plus 5 sums of 6 is 9 sums, 9 out of 36. So that's 25%. Okay? Now, I could do it this way, right? I could instead say it's the probability that I get a sum of 5 plus the chance that I get a sum of 6, right? And this is why? This is by axiom 3. It's by axiom 3 because those are disjoint events. And so what's the chance that I get a sum of 5? It's 4 out of 36 plus 5 out of 36, and you get the same thing. Okay, you see that? You get exactly the same thing. That's because they're disjoint. Okay, or it's actually, I'm applying axiom 3 because they're disjoint. Okay, all right. But on the other hand, what's the probability that I get a sum of 5 or say that I get a at least 1, 2. 2. Okay. Well, now I'll try doing this both ways, right? First, I'll count up the number of ways to satisfy this event that I get a sum of 5 or at least 1, 2. Sum of 5 or at least 1, 2. Sum of 5. Here's my sum of 5. Where do I get at least 1, 2? That's right here, right? You see all those? At least 1, 2. Okay, so I need to count all those. That's 6 plus 5 is 11. 12, 13, I think. I think that's 13 out of 36. Okay, 13 out of 36. Or I could do it like this, right? It's the same, it should be the same as the chance that I get a sum of 5 plus the chance that I get a sum plus the chance that I get at least 1, 2, right? No, this is not going to be true because these two events, this event in here and this event in here, are not disjoint. They overlap, right? They overlap right here. They overlap right there. So I've got to subtract off their intersection, okay? So it's minus the chance that I get a sum of 5 and at least 1, 2. Okay? So now what's the chance that I get a sum of 5? That's 4 out of 36. Plus, what's the chance that I get at least 1, 2? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 36. Minus, what's the chance that I get a sum of 5 and at least 1, 2? That's 2 out of 36. Okay, so that comes out to be, that's 13 out of 36. How about that? Same. These are the same. Okay, two different methods, but you get the same thing. Okay, one way I'm doing counts to get the numerator and counts to get the denominator, and the other way I'm using that general addition rule there that we covered right after axiom 3. In general, if you're going to find the chance of the union of events. It's the sum of the, you could write it as the sum of the chances, but subtract off the chance of their intersection. Okay. All right. So let's do another example here. Remember the example on lions and bears? We've got L1, L2, L3, L4, B1, and B2, right? We've got 4 lions and 2 bears. Oops, 4 lions and 2 bears. Then let's let A be the event that, well, first of all, we're going to pick 2 at random from that set. Okay, let's let A be the event that we get 2 lions. Okay. Then what's the probability of A? Well, first of all, how many possible things can happen here? If you're picking 2 from 6, that's 6 choose 2. That's the total number of outcomes there. Now, how many ways can you get 2 distinct lines? Can you get 2 different lines? You get these 2, these 2, these 2, these 2, these 2, these 2. That's 6, right? Or it's 4, 1, 2, 3, 4, choose 2. Right? Now, 4 choose 2. I know that's 6 because I just counted it on my fingers, right? But what's 6 choose 2? That's 6 factorial over 2 factorial times 4 factorial, right? Okay, so all this comes out to be 6 over, let's see, 6 times 5, 30, 15, 6/15, I think, or 2/5. Okay. Now, what's the probability, though, that you get at least 1 lion? Probability that you get at least 1 lion if you're picking these animals at random. Gosh, I don't know. There are a lot of ways to do that. I could sometimes, if an event seems like it could be satisfied a whole bunch of ways, sometimes it might be easier to apply the rule for complements and take 1 minus the chance that you get. What was the complement of that event? No lions. The chance that you get no lions. Okay. So what's the chance that I get no lions? It's just the probability that I get. It's the probability of the event B1, B2, right? So that's 1 minus, gosh, there's one way to do that, out of 6 choose 2. What is 6 choose 2? That's 15, right? So this is 14/15, right? That makes sense? Okay.